Okay, let's talk about evaluating algebraic expressions. Now, in order to evaluate these, we need to first find out what are these? What is an algebraic expression? Well, simply put, it's an expression that contains one or more variables. When I say the word expression, I simply mean a math sentence, a number sentence. That it might include numbers, it might include operations or variables. Something like 3x minus 2. That is an expression. Now, an algebraic expression must contain one or more variables. And as we learned before, a variable is simply a letter that stands for a number. For example, this x in this expression is our variable. So, 3x minus 2 is an algebraic expression. One thing to remember, an algebraic expression, does not have an equal sign. That would make it an equation. Our job here is not to find out the value of the variable. It's simply to simplify this expression as much as we can. So let's jump right in how to evaluate an algebraic expression. Okay, to evaluate, substitute, or you can say replace the variables with their given values and then follow the order of operations. So if you are given an algebraic expression, a lot of the time you're going to be given the value of those variables. Your teacher will tell you, okay, this x here equals 3 or y equals negative 2. If you are given the value of the variables, how much they are worth, then you can plug those in, or you can substitute them in place of the variables, and you can simplify that by following the order of operations. So let's look at some examples here. Okay, I have an algebraic expression, 7x minus 2y, and I have two variables in this expression, x and y. And if you look over here to the right, I have given you the value of both of these variables. X is equal to 4 and y is equal to 3. Okay, so what I'm going to do, I'm going to rewrite this expression, but in place of those variables, I'm going to write the value of the variable that I've given you. One important thing to remember is that when you have a number, and we'll call that a coefficient, this 7, and a variable right beside each other, the operation going on there is multiplication. So one very common mistake is when someone is just beginning to evaluate expressions is that they rewrite 7x. They say, okay, 7, and then this x is worth 4. Oh, this is 74. Well, that's not the case. We do have some multiplication going on between the 7 and the x. When you read this expression, you can call it 7 times x minus 2 times y, if that makes it easier. So let's go ahead and rewrite this. 7 is going to stay the same, and remember we are multiplying times x. So you are more than welcome to write times x. I prefer to use a parentheses because now that we're into some algebra, we're going to be seeing a lot of the letter x. So I prefer to use parentheses for multiplication. Okay, so I'm going to replace that x with a 4. 7 times 4 minus, I'm going to do the same thing with the y. 2 times the value of the y is 3. So now we've replaced x and y with 4 and 3. Now all we have to do is use our order of operations and solve, and this should come as nothing new to you. So we don't have any parentheses or exponents. We do have multiplication, so we're going to work left to right. 7 times 4 is 28. 2 times 3 is 6. And then 28 minus 6 is, of course, 22. And we have evaluated that algebraic expression. It's as simple as that. Okay, a squared, or a to the second power, plus 2b. Same process. Those exponents can be a little bit tricky, but let's just plug these guys in and see what happens. Okay, as you can see to the right, I have given you the value of both of my variables. A is equal to 4, b is equal to 5. So let's rewrite this. In place of my a, I'm going to write 4. Alright, I was finding a squared, so I'm going to be finding 4 squared plus 2. And remember, when you have that number and the variable right beside each other, the operation going on there is multiplication. So instead of 2 times b, I have 2 times 5. Okay, if you remember your order of operations, parentheses comes first. There are no parentheses here. This parentheses simply stands for multiplication, so there's nothing to do within that parentheses. So the next step in order of operations is exponents, and we actually do have exponents here. 4 squared, remember that means 4 times itself 2 times, which is 16. I'm going to go ahead and bring the rest down, plus 2 times 5. Alright, next step, multiplication and division, I do have that. 2 times 5 equals 10. Bring on the rest of my expression, and last step, going to add 16 plus 10, of course, is 26. and we have evaluated this algebraic expression. A squared plus 2b when a equals 4, b equals 5 equals 26. All right, a couple more examples here. Okay, this one looks a little scarier simply because I've thrown in a fraction. 1 over 2, or 1/2 times r plus s. Well, before we start doing operations, let's go ahead and start evaluating and plugging in or substituting the values of this r and s. Look to the right, you can see I've given you r equals 19, s equals 7. So let's rewrite it. 1/2. Remember, this parenthesis simply means I'm going to multiply. R is 19, s is 7, close parentheses. Okay, order of operations, do we have parentheses? Oh, in this case we do have some parentheses. So let's go ahead and evaluate what is in parentheses. 19 plus 7, of course, is 26. Okay, 26. Now, there's nothing else to do within the parentheses, but I'm going to put the parentheses here because I do have this 1/2 times whatever is in parentheses. If you wanted to write it like 1/2 times 26, that wouldn't hurt anything. Okay, so going back to how we multiply fractions in our last lesson, we're going to make this a whole number into a fraction. So let's rewrite this as 1/2 times 26 over 1, because any whole number over 1 is simply the same value. 26 is equal to 26 over 1. Remember, multiplying fractions, we multiply straight across. Numerator times numerator. 1 times 26 is 26. 2 times 1 is 2. Right? That is an acceptable answer. If you want to divide or simplify this, 2 will go into both 26 and 2. 2 will go into 26 13 times. 2 will go into 2 1 time. And if you remember what I said earlier, any number over 1 is simply equal to that number. So we just simplified 26 over 2 into 13. All right. Now, throw in a few more things at you. I've got a negative here. So first negative we've seen. So let's jump in. Negative 5a plus 2 times a times b minus c, close parentheses. Okay. One thing to remember, if you see over here, I've actually got a here twice. Okay. When we have an expression, within one expression, a variable can only have one value. So this a throughout this whole expression is always going to be worth 2, what I told you over here. So anytime we replace or substitute a, always substitute it with 2. Okay, well, let's go ahead and jump right in and start evaluating. Negative 5a, well, a is equal to 2, so negative 5 times 2 plus 2 times, now a, b right beside each other is the same thing as having a number right beside a variable. A is 2. You're more than welcome to write 2 times 1, which is b. You can put some brackets instead, whatever, as long as you know that you're multiplying a times b, minus c, which is negative 5. Now don't forget, I've got a minus sign there, and the 5 also has a minus sign. So don't just see the minus and be like, oh, it's already there, I don't have to rewrite it. You do have to rewrite it here. Okay? I do have double signs there when I rewrite it. Okay, so if you want to, you can do one of two things here. Remember, going back to our order of operations or operations with integers, when you have double signs like this double negative here, these two negatives, we can't have a double sign. So if you remember in our previous lessons, two negatives right beside each other, they're going to end up being a positive. So you are more than welcome to just erase those two minuses and write a plus, or you can come down here and rewrite the entire problem and just replace it. 2 times 1 plus 5, if that works for you. Okay, I like to rewrite it any chance I get just to make it a lot neater for me because my handwriting is terrible. Okay, order of operations, now that we have all of our variables substituted with their values. Okay, parentheses first. I do have parentheses. Now in this case I have a couple of different operations going on within the parentheses. Okay, when you look inside parentheses and you have more than one operation going on, you basically are going to start over your order of operations. Okay, inside this parentheses I do have multiplication and addition, and we know that multiplication comes first in our order of operations. So 2 times 1 is 2. All right, bring down the rest. Plus 5, 2 plus 2, negative 5. Okay, one step at a time. It's going to look long, but it's not that bad. Okay, we still have operations within the parentheses to do, so we need to finish that on first. We have 2 plus 5, which is, of course, 7. Bring down my 2 plus 2, negative 5. Okay, we're finished with parentheses. There are no exponents here. Our next step is multiplication and division. We do have some multiplication here. Remember, we have two numbers we're multiplying here, so we work from left to right. Negative 5 times 2, our integer rules tell us a negative times a positive is a negative. So negative 5 times 2 is negative 10. And 2 times 7, if you want to do it in the same step, you can. If you want to bring this all down again, you can do that also. Okay, so now do our next parentheses. 2 times 7 is 14. Bring down the rest. And negative 10 plus 14, if we remember, if we have the same signs, we add. We have different signs, subtract. We have different signs here. So 14 minus 10 is 4. Keep the sign of our bigger number. Our bigger number is 14, and it is positive. So our answer to all of this is simply 4. Okay, now this looks like a lot. I did rewrite it after every single small step that I did. If you feel comfortable, go ahead and erasing those and writing a plus sign and go ahead and starting on your order of operations in the same step. You're more than welcome to do that. But for me, it helps me if I just rewrite my expression every single step of the way.